Why do the Denver Broncos have a particular advantage at Invesco Field at Mile High?
After the original Mile High Stadium was demolished in 2001, the Denver Broncos moved to Invesco Field to play football. Here, as with other teams in Denver, such as the Rockies, players have a distinct advantage over visiting teams because their lungs are already accustomed to the higher altitude. Fortunately, the human body can quickly adapt, and if a visiting athlete is able to arrive in the Denver area a couple days before a game, he or she should be able to play on a PAR with the locals.
What country can claim to have the worst weather?
That redoubtable distinction goes to the United States of America. Subjected to hurricanes, flooding, drought, heat and cold waves, blizzards, and the worst tornado activity on the planet, the United States experiences more weather disasters than any other nation.
What is a storm surge?
Not to be confused with a tsunami, a storm surge is a sudden upwelling of ocean water caused by winds and pressure changes affecting the water's surface. Hurricanes generate large wave swells that radiate outwards in all directions as they travel over the ocean. The swells, which can move toward the shoreline about 3 or 4 times faster than the actual storm, arrive on land before hurricanes strike. Before advanced weather systems and the use of satellites, these swells warned people that a hurricane was approaching. The swells become storm surges by the time the main storm arrives, raising water levels as much as 25 feet, 7.5 meters, and causing massive coastal flooding. By some estimates, the storm surge resulting from 2005's Hurricane Katrina was 28 feet, 8.5 meters.
What military battle was cancelled because of a mirage?
During World War I, a battle between British and Ottoman forces in April 1916 was cancelled because a mirage made it impossible for the combatants to see one another.
What is the National Weather Center, NWC?
The NWC is a partnership between the National Oceanic and Atmospheric Administration, state organizations, and the University of Oklahoma. It is a scientific endeavor to better understand the weather, especially on a macro scale involving long periods of time and all levels of the atmosphere.
What is long-range transport?
Long-range transport refers to the fact that winds, especially high-altitude winds, can carry pollutants over incredibly long distances. People once believed that pollutants from sources such as smokestacks might travel a few miles before settling onto the ground and water supplies. Now it is known that these particulates and toxic gases can make their way into the upper atmosphere. Scientists first started to become aware of this issue in the mid-20th century, when nuclear bomb tests resulted in radioactive clouds that would circumnavigate the planet. Acid rain-causing chemicals can easily cross the entire United States. And, likewise, pesticides and herbicides travel long distances. Natural air pollutants, such as volcanic ash and organic material like fungi, spores, and pollen, can similarly range over long distances.
What is an ENSO neutral year?
An ENSO neutral year is a year during which neither El Niño nor La Niña conditions are present.
Is Chicago really the Windy City?
Chicago is not the windiest city in the United States. It actually got the nickname of the Windy City because of its reputation for being the home of blowhard politicians. Chicago's average wind speed of 10.4 miles, 16.7 kilometers per hour is exceeded by Boston 12.5 20.1, Honolulu 11.3 18.2, and Dallas and Kansas City, both 10.7 17.2.
What U.S. city is particularly noted for its problems with smog?
Los Angeles has a rough time with smog. The brown haze that often lingers over the city is a result of several factors. Of course, the urban area is filled with cars and other sources of pollutants. But the natural environment conspires to make matters worse. First of all, very little rain falls in LA, which might attract tourists and new residents but does nothing to wash away pollutants, and secondly, the city is in a basin surrounded by mountains. Ocean breezes blowing in from the west keep air pollution from escaping in that direction. But then the smog finds another barrier in the mountains that lie east, north, and south of the city. Even before Spanish and other European settlers came to the area, the Native American Chumash tribe called what is now Los Angeles the Valley of Smoke, because haze from brush fires and dust would be trapped there for long periods.
When are you most likely to see sprites and blue jets?
The best chance to see one of these brief, strange lights is in the middle of the night. when you are near a strong thunderstorm and far away from the light pollution of a city or town. The storm should be more than 100 miles, 161 kilometers away, but no more than 300 miles, 482 kilometers, distant. Estimate the height of the storm clouds. Then multiply that by 8 to get the approximate altitude where the sprites and blue jets may appear. Sprites may appear as reddish, orange, white, or even greenish flashes. Blue jets are even harder to see, but you are more likely to view them if the storm includes hail.
Where does it snow on the equator?
Mountainous regions on or near the equator regularly get snow. For example, it snows in the Andes Mountains in Ecuador. And in Africa snow falls on Mt Kenya and Mt Kilimanjaro.
What is a certified consulting meteorologist, CCM?
The American Meteorological Society, AMS, grants the title of CCM to professional meteorologists who have both broad experience in meteorology and a highly specialized knowledge of particular fields on which they intend to consult. In addition to education and experience, a meteorologist has to demonstrate professional conduct and service to be named a CCM. They are sought out by law firms, governments, law enforcement agencies, insurance companies, and other private businesses for their expertise and for the assurance that all CCMs will provide reliable and authoritative information. Only about 5% of AMS members are CCMs. The AMS provides a listing of CCMs by specialty on its website at http://www.amtsoc.org.
What are tornadoes?
Tornadoes are very powerful, yet tiny storms that have destructive winds capable of leveling buildings and other structures. Winds in a tornado form a dark gray column of air, though white, bluish, or even red is possible, depending on how the sun's light rays might be reflecting off the tornado, with the center of the tornado acting like a vacuum, picking up objects and moving them along the storm's path. Tornadoes can last from a few minutes to an hour or more. They are one of the most destructive forces in nature, with the largest tornadoes sometimes having diameters of over 1 mile, 1.6 kilometers. And wreaking a path of destruction over 100 miles, 160 kilometers, long.
What is the tropopause?
He learned that, after about 7 miles, 11 kilometers, The air stopped becoming cooler and leveled off for as high as the balloons could go. He concluded that the atmosphere was divided into two layers, which he named the troposphere and the stratosphere. Later, in the 1920s, meteorologists Gordon Miller-Bourne Dobson, 1889–1976, and F. A. Lindemann, first Viscount Cherwell, 1886–1957, used studies of meteor trails to learn that temperatures warmed in the atmosphere as high as 30 miles, 48 kilometers, up. Dobson concluded that ultraviolet radiation absorbed by the ozone in the stratosphere was the reason for the warmer air.
Why are there so many discrepancies in the world records of weather?
The discrepancies in the data reflect the length of time that we use to measure weather phenomena. Some records were set by observing the weather over decades. Others only occurred during the span of a few years or months, or even hours or minutes. Discrepancies also exist because of the various types of instruments that were used over the years, and how they were exposed to the elements.
What is a pulse Doppler radar?
Pulse Doppler radars, or simply pulse radars, are designed to better track the velocity of clouds, winds, and precipitation. They use radar in short, strong bursts with long intervals in between. To get accurate measurements, several pulse radars must be used in conjunction.
Why do you sometimes see double rainbows?
Sometimes rainbows form that have a fainter twin called a supernumerary rainbow. The twin will be bigger and above the first rainbow, and the colors of the bands will be reversed. This occurs when not all of the light is reflected out of the raindrops at once. Some light energy remains, and is reflected within the droplets before emerging as a second rainbow.
What is bioclimatology?
Bioclimatology is the study of the effects of the climate on living things. Weather and atmospheric conditions can affect humans in many ways, both positive and negative. Our climate affects our moods, the chemical content of our bodies, the chances of getting a disease, and more. In Europe, awareness of the importance of bioclimatology has resulted in weather forecasts that include warnings of possible health hazards. The United States has not kept up with this pace, but meteorologists in America do often warn of such hazards as air pollution and allergen levels, as well as temperature extremes that might be dangerous because of frostbite or heat stroke.
How much rain does it take to make a flood?
The amount varies widely for different areas. In some U.S. western deserts, or in some large urban areas, just a few minutes of strong rain will cause a flash flood in canyons and low-lying areas. In areas prone to greater rainfall amounts, it often takes quite a bit more rain. Sometimes a few days or weeks' worth, to cause rivers to overflow and dams to fill up, raising concerns of those who live downstream. Areas that normally receive more rainfall have better natural drainage systems and are usually home to plants that readily absorb the extra water.
What is a blue sun?
An even rarer event than a blue moon is a blue sun. As with a real blue moon, the sun can appear bluish as a result of fires, volcanic eruptions, or sandstorms coating the air in dust, ash, or sand.
How much land disappears when the sea level rises?
Scientists believe that as the sea water rises by 0.04 inches, 1 millimeter, the shoreline disappears by 4.9 feet, 1.5 meters. This means that if the sea level rises by 3.28 feet, 1 meter, the shorelines will extend another 1 mile, 1.6 kilometers, inland.
Do meteorologists actually have reliable data on tornado wind speeds?
No, and that is a big part of the problem in categorizing tornadoes. Tornado wind speeds have been scientifically estimated using Doppler radar and video observations. But there have been no successful attempts to physically measure speeds using an anemometer.
What is a katabatic wind?
A katabatic wind develops because of cold, heavy air spilling down sloping terrain, e.g., a chinook, moving the lighter, warmer air in front of it. The air is dried and heated as it streams down the slope. At times, the falling air becomes warmer than the air it restores.
What are some other effects of ultraviolet radiation?
Small amounts of ultraviolet, UV, radiation can actually be good for you because it aids in the production of vitamin D in the body. However, you only need about 10 to 15 minutes of sunlight exposure a day to get this benefit. Not getting enough sunlight leads to vitamin D depletion, which can lead to depression and other symptoms in humans and is, indeed, a chronic problem in populations located in northern and extreme southern climates. Besides the risks of cancer, especially melanoma, overexposure to UV radiation can cause cataracts or inflammation of the cornea, snow blindness. If exposure is not too long, the eye can heal itself from this inflammation. But prolonged exposure could lead to permanent blindness. Cancer of the eye is also a possibility. It is also believed that too much UV radiation weakens immune systems. Those studies are still being conducted to more fully understand this health risk. Interestingly, it has also been found that in areas where ozone levels are lower and more UV radiation penetrates to ground level, certain construction materials such as wood and some plastics degrade at a higher rate than normal. High UV levels also, of course, affect plants and animals, though some are at a higher risk than others. Scientists have learned, for example, that soybean crops and some types of rice could die if the ozone were too severely depleted. Also, young pine tree needles are damaged by UV light. But mature needles, which have a waxy coating, are protected. In the oceans, some forms of plankton could die or be severely depleted if the ozone was not doing its job. The result would be a breakdown in ocean food chains that could be devastating. The effects on wild animals are not well known, though nocturnal animals would likely be unaffected. And many diurnal animals have fur or feathers that protect them from radiation. However, skin around the eyes and ears are often more exposed to the sunlight. And animals would be as susceptible to eye problems as much as humans.
Did people in ancient times really believe lightning came from the gods?
The power of lightning has impressed cultures for millennia. People, indeed, felt that it was a divine event and that lightning held mystical powers. The Romans and Greeks viewed them as spears, which were forged by the god Hephaestus. Vulcan, in Roman mythology, and then wielded by Zeus, or Jupiter, in Rome. Norse mythology gives the chief god, Odin, a spear made of lightning that he names Gungnir. And the Hindus also gave their god of war and weather, Indra, a thunderbolt weapon. Sometimes, lightning was used as a symbol in these cultures. The Mayans used a triple lightning symbol to represent Hurricane, a god of creation who controlled the powers of wind, fire, and storms. There was also a belief, interestingly held by the Mayans, the Romans, and in Hindi culture, that mushrooms would grow in places where lightning struck.
How much of the sun's energy is radiated back into space by the Earth?
As the sun provides us with energy, it is also being reflected back into space. Because this give and take is in balance, our planet stays at pretty much the same total temperature, which is a very good thing. If Earth reflected back more energy than it received, the planet would cool, eventually becoming an ice ball. If the opposite happened, as some scientists fear could be occurring with global warming, the planet would heat up. Interestingly, some planets, including Jupiter and Neptune, radiate much more heat than they receive, which has led to speculation that there is a heat source within these planets. Some astronomers consider Jupiter a kind of failed star. If it had been more massive, it could have become a second sun, and Earth would be part of a binary star system.
What is a profiler?
Profilers use electromagnetic waves the same way that sonars use sound waves. This strategy has proven ideal for penetrating deep into the upper atmosphere, where meteorologists can then determine wind speeds at altitudes 5 to 10 miles, 8 to 17 kilometers, high.
How tall can thunderstorm clouds be?
Even a fairly average thunderstorm has a height of more than 20,000 feet, 6,000 meters. With the tallest storms being reported at over 70,000 feet, 21,000 meters.
What is the thermocline?
Imagine the water in a sea or ocean as being similar to very dense air in the atmosphere. Just like with the air, layers of water can have different temperatures and pressures, with warm waters generally being on top of colder layers of water. The difference between the temperatures in these layers is called the thermocline.
What is a low-high temperature and a high-low temperature?
When meteorologists look at daily temperature, there is always a low and a high temperature for each day. If the high temperature is the coldest high temperature for that day or for the month on record, you have a new record, a new low high. Conversely, if the low temperature for a day is quite warm and breaks records, that's a new high low.
What is the Wolf number?
Swiss astronomer Johann Rudolf Wolf, 1816 to 1893, devised a system for counting sunspots in 1848. The Wolf number is named in his honor. Astronomers count sunspots from various observation points across the globe, then average those counts to come up with the official Wolf number for that period.
How did abrupt climate changes in the past come to be called Donsgardeshger events?
Danish geophysicist Willy Donsgaard, 1922, discovered that by measuring the levels of oxygen isotopes and deuterium, a hydrogen isotope, in glaciers, as well as dust content and the acidity of ice, it was possible to reconstruct what the Earth's climate was in the past. He came about his conclusion by studying ice cores drilled out of glaciers in Greenland in the 1960s with Swiss physicist Hans Escher. 1927 to 1998, the inventor of the Escher counter, a radiation measuring device. Escher and Donsgaard drilled ice core samples dating back some 150,000 years in Earth's history. Layers in the ice showed that there had, in that time, been 24 abrupt changes in the world's climate. These are now called Donsgaard-Escher events.
Who first discovered cosmic rays?
The Austrian-American astronomer Victor Franz Hess, 1883 to 1964, became interested in a mysterious radiation that scientists had found in the ground and in Earth's atmosphere. This radiation could change the electric charge on an electroscope, a device used to detect electromagnetic activity even when placed in a sealed container. Hess thought that the radiation was coming from underground, and that at high altitudes it would no longer be detectable. To test this idea, in 1912 Hess took a series of high-altitude hot air balloon flights with an electroscope aboard. He made 10 trips at night, and one during a solar eclipse, just to be sure the sun was not the source of the radiation. To his surprise, Hess found that the higher he went, the stronger the radiation became. This discovery led Hess to conclude that this radiation was coming from outer space. For his work on understanding cosmic rays, Hess received the Nobel Prize in Physics in 1936.
What is an urban heat island?
Because urban areas are generally devoid of significant vegetation, the concrete and other construction materials for buildings and roads prevent the heat from the sun from being absorbed. Instead, surfaces become hotter and drier. Cities and towns become warmer than surrounding rural areas to the point where, on a warm summer day, surfaces such as sidewalks and roofs can be as much as 50 degrees to 90 degrees Fahrenheit, 27 to 50 degrees Celsius, hotter than the surrounding air. The warming effects are especially pronounced during the day, but the temperatures are also affected at night. According to the U.S. Environmental Protection Agency, a city of about 1 million people can cause the surrounding atmosphere to heat up as much as 22 degrees Fahrenheit, 12 degrees Celsius, more than it would be under similar weather conditions in a rural area. Annually, the effect would be that the overall temperature for a city that size would be 1.8 to 5.4 degrees Fahrenheit, 1 to 3 degrees Celsius, higher than in the surrounding areas. There are several problems that result from heat islands. People tend to use their air conditioners and other utilities more. thus increasing energy consumption. This leads to more pollution, including greenhouse gases. These pollutants also affect human health. Finally, rainwater that has fallen onto heated surfaces on pavement and roofs flows into sewers, and then into the environment, where the heated water affects wildlife.
How do you convert inches of mercury to millibars?
When measuring air pressure, sometimes inches of mercury are used, and sometimes millibars. To convert inches of mercury to millibars, multiply the number of inches by 33.86375526, or 33.86 will give you an accurate enough measurement. To do the calculation in reverse, multiply millibars by 0.0295301, or 0.03 for an estimate, to give you inches of mercury.
What are Aeolian sounds?
The somewhat musical, sometimes mournful sound wind makes when blowing across branches, wires, or circular objects is called an Aeolian sound. Aeolus was the Greek god of wind. An Aeolian is a musical term used to refer to wind instruments or to a diatonic scale.
Are some people allergic to the cold?
Research indicates that some people are, indeed, allergic to cold temperatures and may develop a rash as a result. Antihistamines can relieve symptoms, just as they do with exposure to other allergens.
What is air pollution?
Air pollution is caused by many sources. There are natural pollutants that have been around as long as the Earth, such as dust, smoke, volcanic ash, and pollens. Humans have added to air pollution with chemicals and particulates. Due to combustion and industrial activity, anthropogenic sources.
What months are the most likely times for tornadoes?
The height of the tornado season in the United States is March through August. Though tornadoes do form in the south during the off-season, more tornadoes occur in May than any other month. But more deaths have been logged during the month of April. One of the worst outbreaks of tornadoes ever recorded ran from April 3 through 4 in 1974. 13 states: Illinois, Indiana, Michigan, Ohio, Tennessee, Kentucky, Alabama, Mississippi, West Virginia, Virginia, North Carolina, South Carolina, and Georgia, saw 148 tornadoes touch down. killing 315 people and injuring almost 5,500. The tornadoes cut through 2,500 miles, 4,000 kilometers, of terrain.
Where are aurorae seen?
Aurorae are most prominent at high altitudes near the North and South Poles. They can also be seen sometimes at lower latitudes on clear nights. Far from city lights, every once in a while, perhaps once every year or so, aurorae can be seen as far south as the lower 48 states of the United States. Displays of aurorae can be amazingly beautiful, varying in color from whitish green to deep red and taking on forms like streamers, arcs, curtains, and shells.
What are cooperative weather observers?
While the U.S. government funds many weather stations throughout the country, the cost of supporting all of the stations that would be necessary to fully observe the weather everywhere would be prohibitive. Thankfully, volunteers known as cooperative weather observers assist by taking readings and measurements about winds, temperatures, precipitation, and so forth. Providing this data to meteorologists in cooperation with the National Weather Service and the National Climatic Data Center.
Does dew fall?
While this is a common expression, dew does not actually fall. A point that was proven in a demonstration conducted by Scottish-American physicist William Charles Wells, 1757 to 1817. In 1814, Wells showed that dew actually formed on surfaces as water vapor condensed.
Has lightning ever happened during a snowstorm?
Yes, it is possible to have lightning and thunder when it is snowing. In fact, winter storms have been known to produce very powerful lightning strokes.
About how many tornadoes are recorded in the United States annually?
A typical tornado season sees about 800 tornadoes in the United States. However, better observational techniques, including advanced Doppler radar and growing numbers of tornado chasers, has led to increases in tornado observations since around 1990. So this official average might go up.
What is the solar spectrum?
The solar spectrum is the spectrum of light that includes wavelengths both visible and invisible to the human eye. when diverted through a prism. This white light separates into the familiar rainbow spectrum of colors, ranging from violet to red. Temperature is affected by the longer wavelength spectrum, read through invisible infrared. About 50% of the sun's spectrum emerges as wavelengths at the infrared level, and 10% are in the ultraviolet range.
How much do meteorologists earn?
You should never pick a career solely based on its earning potential. Pick something you love, and then go from there. That being said, meteorologists make very good wages indeed. As of 2009, average salaries ranged from $70,000 to $108,000 annually. On the low end, the salary for a degree-holding meteorologist was about $53,000, at the upper end. A meteorologist in a specialized field with a PhD can easily make $125,000 a year.
Is there a difference between the Farmer's Almanac and the Old Farmer's Almanac?
The Old Farmer's Almanac was first published in 1792 under the editorial leadership of Robert B. Thomas, 1766 to 1846, and is currently published out of Dublin, New Hampshire. The similarly titled Farmer's Almanac debuted in 1818 in Ohio. The founding editor was David Young, d. 1852, and the publication is now headquartered in Lewiston, Maine. They are, indeed, different publications, although more confusion arises from the fact that initially, the Old Farmer's Almanac was called the Farmer's Almanac for a number of years. Both, though, are almanacs, which means they include information about upcoming astronomical events, such as tides, sunrises and sunsets, lunar cycles, and so on. For added interest, they include cooking recipes, gardening tips, nature news, and advice columns. Published annually, they also both make predictions about the weather for the coming year, which is what made them desirable books for farmers to own. Both books claim to have secret formulas for predicting the weather the most accurately, with the Old Farmer's Almanac claiming it has an accuracy of 80%. Meteorologists dispute such claims, though, and also note that the almanacs make broad generalities about weather forecasts that makes them hard to refute. For instance, a prediction for spring might say that the Midwest will experience more rain than usual.
What countries are threatened the most from rising sea levels and may cease to exist in the 21st century?
Low-lying island nations of the Pacific and Indian Oceans are most at risk, most notably Tuvalu and the Maldives. Other candidates for severe flooding and reclamation of coastal land by the impending sea include Bangladesh, India, Thailand, Vietnam, Indonesia, and China, affecting the lives of hundreds of millions of people.
What is odor pollution?
Odor pollution is simply the unpleasant stench of such things as garbage, sewage, chemicals, rotting organic matter, and hazardous waste. Human beings can detect foul odors at concentrations as low as 1 part per trillion, depending on what the chemical is. This is important because people can actually detect air pollutants. Except for odorless ones such as carbon monoxide, at levels much lower than can be detected by instruments. This is especially true of the smellier pollutants, such as hydrogen sulfide. H2S, which produces that familiar rotten egg smell, even when diluted in water. Hydrogen sulfide pollution can cause everything from eye and throat irritation to asthma attacks and even death.
What are keratophobia and brontophobia?
Keratophobia is the fear of lightning. And brontophobia, sometimes called tonitrophobia, is the fear of thunder.
What is convection?
Convection is the transfer of heat vertically through the atmosphere via a liquid medium, e.g. water droplets.
What is a superior mirage?
A superior mirage, also called a superior image, refers to the illusion that occurs when light from objects is refracted in a way that makes them appear as if they are floating in air above the actual object. This can occur when warm air blows over cooler surfaces, the opposite of a common mirage.
But how do they form?
One argument is that they come from airplanes, but not from toilet drainage, because this would mean contaminants and cleaners would be found in these large ice stones. However, ice might still form and break off of airplanes while in flight. And since it could take as much as 3 minutes for such a piece of ice to reach the ground, such meteors might seem to come from out of the blue because the jet plane is long gone by then. A growing number of meteorologists, however, do not buy into the airplane scenario. They speculate that cooling and water vapor conditions within the tropopause that are still little understood may explain the formation of meteors. Regions are the Central Plains in the United States and Canada, Central Europe, and parts of the Ukraine, Southern China, Argentina, and parts of Central and South Africa and southeastern Australia.
How was seafloor spreading discovered?
In the 1950s, scientists realized that as igneous rocks cool and solidify, crystallize, magnetic minerals align with the Earth's magnetic field like tiny compass needles, essentially locking the magnetic field into the rock. In other words, rocks with magnetic minerals act like fossils of the magnetic field, allowing scientists to read the rock and determine the magnetic field from the geologic past. This is called paleomagnetism. The idea was proposed by Harry Hess, 1906 to 1969, a Princeton University geologist and U.S. Naval Reserve Rear Admiral, and independently by Robert Dietz, a scientist with the U.S. Coast and Geodetic Survey, both of whom published similar theories that became known as seafloor spreading. In 1962, Hess proposed the idea of seafloor spreading, but had no proof. As Hess formulated his hypothesis, Dietz independently proposed a similar model, which differed by noting the sliding surface was at the base of the lithosphere, not at the base of the crust. Support for Hess's and Dietz's theories came only 1 year later. British geologists Frederick Vine and Drummond Matthews discovered the periodic magnetic reversals in the Earth's crust, taking data from around mid-ocean ridges. Seafloor spreading areas, Vine noted the magnetic fields of magnetic minerals showed reversed polarity. The Earth's magnetic field has reversed its polarity around 170 times in the last 80 million years. From the spreading center outward, there was a pattern of alternating magnetic polarity on the ocean floor, swaths of opposing polarity on each side of the ridge. As the spreading center continues to grow, new swaths develop, pushing away material on either side of the ridge. Thus, these strips of magnetism were used as evidence of lithospheric plate movement and of seafloor spreading.
How many layers does the Earth's atmosphere contain?
The atmosphere, or skin of gas that surrounds the Earth, consists of 6 layers that are differentiated by temperature. 1. The troposphere is the lowest level. It averages about 7 miles, 11 kilometers, in thickness, varying from 5 miles, 8 kilometers, at the poles to 10 miles, 16 kilometers, at the equator. Most clouds and weather form in this layer. Temperature decreases with altitude in the troposphere. 2. The stratosphere ranges between 7 and 30 miles, 11 and 48 kilometers, above Earth's surface. The ozone layer, which is important because it absorbs most of the sun's harmful ultraviolet radiation, is located in this band. Temperatures rise slightly with altitude to a maximum of about 32 degrees Fahrenheit 0 degrees Celsius. 3. The mesosphere, above the stratosphere, extends from 30 to 55 miles, 48 to 85 kilometers, above the Earth. Temperatures here decrease with altitude to -130 degrees Fahrenheit -90 degrees Celsius. For the thermosphere, also known as the heterosphere, is between 55 to 435 miles, 85 to 700 kilometers, above Earth's surface. Temperatures in this layer range to 2696 degrees Fahrenheit 1475 degrees Celsius. 5. The ionosphere is a region of the atmosphere that overlaps the others, reaching from 40 to 250 miles, 65 to 400 kilometers. In this region, the air becomes ionized, electrified, from the sun's ultraviolet rays. It is divided into 3 subregions: 1. The D region, 40 to 55 miles 65 to 90 kilometers. 2. The E region, also called the Kennelly-Heaviside layer, at 56 to 93 miles. 90 to 150 kilometers, and 3, the F region, 93 to 248 miles 150 to 400 kilometers, which is further separated into the F1 layer and the F2 layer, also called the Appleton layer, with the dividing line being at about 150 miles, 240 kilometers, above sea level. 6. The exosphere lies above the thermosphere and includes everything above 435 miles, 700 kilometers, high. In this layer, temperature no longer has any meaning.
What is an ionospheric storm?
When a coronal mass ejection, solar flare, occurs on the Sun's surface, it can dramatically increase the amount of photoionization in the ionosphere. An overwhelming amount of free electrons in the upper atmosphere results, and this can cause problems with radio communications.
When did radar finally catch on, and who gets the credit?
In 1935, over 3 decades after Hulsmeyer first proposed the idea, radar technology came into its own through the work of British scientist Robert Watson Watt, 1892 to 1973, along with H. E. Wimperis, 1876 to 1960, Henry Tizard, 1885 to 1959, and A. F. Wilkins, working for the British government. Watson Watt was given the assignment of investigating whether Germany's Adolf Hitler could carry out a threat of creating a weapon using radio waves. Watson Watt knew this was an impossibility, but he saw another potential use. Using shortwave radio transmitters from the British Broadcasting Corporation, he and his colleagues created the first practical radar technology. Radar was used to detect attacking German airplanes during World War II, and was credited with swaying the 1940 Battle of Britain in England's favour.
What was the Little Ice Age?
The Little Ice Age was an interval of relative cold, beginning about 1450 and lasting until about 1890. The coldest periods of 1450 and 1700 are often divided into the two Little Ice Ages. It occurred during the current warm, interglacial period, but is not considered a full glacial episode. Since the high latitudes of the northern hemisphere, land masses remained largely free of permanent ice cover. Even so, much of the world experienced cooler temperatures during this time of at least 2 degrees Fahrenheit. 1 degree Celsius, lower worldwide average surface temperatures. It was a time of renewed glacial advance in Europe, Asia, and North America, with sea ice causing havoc in the colonies of Greenland and Iceland. In England, the Thames River froze. In France, bishops tried to halt glacial advances with prayer. Several historians also believe the low temperatures caused social conflict and poor food production. Thus, this may have been partially responsible for war and hunger during that time. Just like the major ice ages, no one really knows what caused the Little Ice Age. Though English astronomer Edward Maunder, 1851–1928, first hypothesized that it had something to do with solar activity. Other scientists attribute the cooling down to volcanic eruptions, changes in the ocean circulation, changes in the Earth's orbit, the wobbling of the Earth's axis, or even our planet's passage through clouds of interstellar dust.
What is the windiest place on Earth?
MT. Washington, New Hampshire, is the windiest place on Earth that has a weather station to record such data. In 1934, wind speeds were clocked at 231 miles, 372 kilometers, per hour. The average annual wind speed there is 35.3 miles, 56.8 kilometers, per hour. While no official measurements are available, the windiest places in the world are probably found in the coastal regions of Antarctica.
Hey, wait a minute, weren't scientists warning us of an impending ice age back in the 1970s?
Beginning in 1970, there was considerable media attention given to speculation that Earth would soon see a new ice age. A scientific paper published in 1971 by S.I. Rasool and S.H. Schneider at the Institute for Space Studies is often cited as predicting an ice age. The paper was about the effects of aerosol levels in the atmosphere. The authors speculated such levels would rise by 600 to 800% over the next few years, and that this would trigger an ice age. What actually happened was that aerosol levels fell. Even if they hadn't, many scientists believe that Rasool and Schneider were inaccurate in their estimates about how carbon dioxide levels affected temperatures. Nevertheless, this publication and others that cited it drew the attention of the media. leading many people to believe that the next big climactic change would be a cooling off period.
Where does it rain the most in the United States?
Mt. Waialae, on the island Kauai in Hawaii, receives a whopping average of 460 inches. 1,168 centimeters, of rain a year. That's over 38 feet, about 12 meters, of rain per year.
Are there other ways that thunderstorms can be described?
Classifying thunderstorms can be a rather subjective practice. But meteorologists do give different types of storms other names based on how they are formed, including mesoscale convective systems, a large, non-frontal thunderstorm. This classification includes mesoscale convective complexes, which are enormous storm systems that can cover several U.S. states at once and last for half a day or more. Air mass thunderstorm, a common, short-lived, relatively unorganized, and fairly small storm. Sea breeze thunderstorm, cold frontal storms that form as wind blows in toward the coastline.
What is an air pocket?
Air pockets are caused by turbulent air. Many people who have ridden in airplanes are familiar with them, as they cause that bouncing sensation as you hit an updraft, followed abruptly by a downdraft, in quick succession.
What is the purpose of a snow fence?
Snow fences are usually installed in places where there is not much in the way of vegetation or buildings to keep winds from blowing and drifting snow. The fences create wind turbulence that prevents drifting downwind of the fence.
Who were the first people to successfully forecast a tornado?
U.S. Army officers Ernest Fawbush and Robert Miller were the first to correctly predict a tornado would form on March 25, 1948. Recognizing that weather patterns in central Oklahoma were very similar to those that had occurred a few days earlier when a tornado hit Tinker Air Force Base. Fawbush and Miller told their superiors, and a decision was made to warn residents about the possible threat. A tornado again hit the Tinker base a few hours later.
What are the fastest currents in the world's oceans?
The fastest known current is part of the Gulf Stream system. It heads north from the southern tip of Florida toward Cape Hatteras, North Carolina, flowing up to 3.3 to 6.6 feet. 1 to 2 meters per second, with some estimates as high as 7.5 feet, 2.3 meters per second. The Kuroshio current in the Pacific Ocean runs a close second in terms of speed around 1.3 to 4 feet, 0.4 to 1.2 meters per second.
Who first discussed the link between climate change and how gases in the atmosphere absorb heat?
In 1884, American physicist and astronomer S. P. Langley, 1834 to 1906, was the first to publish a scientific paper on how gases in the atmosphere can absorb heat, which has an effect on the Earth's climate.
What is the difference between a tornado watch and a warning?
A tornado watch means that weather conditions within the next few hours are favorable for the formation of tornadoes. When a watch is issued, it is wise to listen to radio or television reports for updates. And you should make any preparations necessary in case you need to seek immediate shelter. A tornado warning means that an actual tornado has been spotted on Doppler radar or by an observer in your area, and you should immediately take shelter.
Has there always been an ozone layer?
No. Before plants evolved on the planet, there was no ozone layer. Because plants are responsible for converting carbon dioxide in the atmosphere into oxygen molecules. So, life on Earth actually began to evolve before there was an ozone layer.
What is a digital barometer?
A digital barometer is an aneroid barometer that works by running an electrical current between two strips of metal. The current measures the distance between these strips, which are affected by air pressure, and translates these into an electronic display.
Can weather actually make pollution worse?
Yes, and it can alleviate it, as well. Rain, for instance, can wash away haze over cities, and wind can blow it away. Stagnant air masses, humid air, or temperature inversions, on the other hand, will allow pollution to build up. During the night, nocturnal inversions cause carbon monoxide to build up around freeways and other high-traffic areas. On the other hand, mixed layer conditions help to disperse pollutants when temperatures decrease over several thousand feet at a rate of about 4.5 degrees Fahrenheit 2.5 degrees Celsius for every 1,000 feet, about 300 meters, or so.
When did the first weather map appear in a newspaper?
The London Times was the first periodical to publish a weather map, which ran in the April 1, 1875, issue. The map was created by Sir Francis Galton, 1822–1911. An English scientist and half-cousin of Charles Darwin. Galton created his map which showed prevailing winds, barometric pressures, and temperatures throughout the British Isles and parts of Western Europe without the advantage of satellites, computers, or even a telephone.
What is the ecliptic plane?
The ecliptic plane is the plane of Earth's orbit around the Sun. Ancient astronomers were able to trace the ecliptic as a line across the sky. Even though they did not know Earth actually orbited the Sun. They merely followed the position of the Sun compared to the position of the stars in the sky, figured out. Despite the Sun drowning out the light of the other stars, where the Sun was every day. And noticed that every 365 days or so the positions would overlap and start going over the same locations again. That line marked a loop around the celestial sphere. Astronomers marked the line using 12 zodiac constellations positioned near and through the loop.